Hey everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about nitrene, electronic state of nitrene, stability of nitrene, generation of nitrene, reaction of nitrene, conclusion and references. So what is nitrenes? What are nitrenes? Nitrenes are uncharged electron deficient monovalent nitrogen species. They are isoelectronic with carbene. The nitrogen atom in nitrene has 6 states of electron. Other names found in literature are imidogens, azacarbene, azenes and imines. Now electronic state of nitrene. In singlet state, there are two pair of electrons, one pair in sp orbital and other pair in a p orbital. One p orbital in singlet state remain vacant. You can see here the singlet state sp orbital and p orbital occupied and p orbital vacant. On the other hand, in triplet state, one electron pair is in sp orbital and two p orbital remain half filled, having electrons in parallel spin. So p orbital half filled triplet state. So triplet nitrene is more stable and represent the ground state electronic configuration of nitrene. ESR spectroscopy also confirmed that the triplet state of nitrene is in the ground state. Now electronic state of nitrene. The energy difference between the singlet and triplet nitrene is usually much larger for nitrenes than that of carbene, that is 145 kJ per mole for nitrene, 32 to 47 kJ mole for carbene. The energy difference is due to the electronegativity difference in carbon and nitrogen. Nitrogen is more electronegative than carbon and therefore it holds its electrons closer to the nucleus, which decreases energy and hence increases stability. Now stability of nitrene. Nitrene are very reactive species and cannot be isolated. However, a nitrene has been trapped by its reaction with carbon monoxide to yield an isocyanate. You can see here the PNH3, it gives this product and further it gives phenyl isocyanate. Nitrene can also be trapped in presence of ethylene. Now generations of nitrene. Decomposition of azides. Thermal or photolytic decomposition of azide give nitrene. You can see aryl sulfonyl azide, it gives aryl sulfonyl nitrene. Now generation of nitrene. Second, oxidation of primary amino group in N-amino compound. N-amino carbazole, it gives nitrene in presence of lead tetraacetate. Deoxygenation of nitro compounds. You can see react with triethyl phosphine types compounds and forming this product, and finally you can see the nitrene. Formation of aziridine. Usually nitrene generated from azide react with olefins to form aziridine. Again azide themselves combine with olefins to form triazolene, which may again decompose photochemically to form aziridines. Now formation of aziridines. You can see like carbene, singlet nitrene react stereo specifically and triplet nitrene react stereoselective through diradical formations. So this is the reactions. Now formation of aziridine. It is to be noted that when an azide is subjected to photolysis or thermolysis, singlet nitrene is formed, and when the concentration of olefin is large, the reaction is mostly stereospecific, but if the reaction medium is diluted with the inert solvent, the singlet nitrene is converted into more stable triplet state by collision with inert solvent molecules, dissipation of energy, and the reaction switches over to stereoselective. You can see the nitrene precursor, singlet nitrene and triplet nitrene. Now, formation of aziridine. Aromatic hydrocarbon react with nitrene to give aziridine first, which undergo ring expansion to give acipenes. So, see the reactions. Now, reaction of nitrene, insertion reactions. Like carbene, nitrene also undergo insertion reaction. Singlet nitrene insert in a concerted manner, and the stereochemistry of the substrate should be retained in the product. So, triplet nitrene could give the same, but by two-step process, two radicals are formed which combine to give the product. So, nitrene intermediate are found to be involved in many intramolecular insertion reactions. If the inner tertiary CH bond is an asymmetric carbon atom, then the configuration at the chiral center should be retained in a concerted manner. You can see in this example, formation of nitrene and then retention of configuration of the chiral center. So, an interesting insertion reaction is observed when orthoazido biphenyl is converted into carbazoles in a good yield. So, both alpha insertion and gamma insertion can occur in a single substrate molecule, leading to a cyclic and cyclic compound. Alpha insertion initially gives an imide, which on hydrolysis gives the corresponding carbonyl compound. You can see the alpha, beta, gamma and delta hydrogens and alpha insertion and then final product. So, metal catalyzed CH insertion and their mechanisms. Now, rearrangement reaction of nitrene. Nitrene also be obtained as reactive intermediate in Hoffman, Curtius, Smith and Lawson. 5 reaction. Remember for the NET examination. Hoffman rearrangement. You can see the formation of nitrene during the reactions. Curtius rearrangement. You can see the formation of nitrene and then formation of isocyanate. Lawson rearrangement. The formation of nitrene in this mechanism. Smith rearrangement, the formation of nitrene. So, this is the reference reaction mechanism in organic chemistry, and Claydon is very important book. So, friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.